In the outer darkness of the solar system, beyond the last giant planet, drifts a world we thought we understood. For decades, Pluto was treated as a frozen relic, a dead fragment abandoned at the edge of sunlight, too small to survive, too cold to change. And in 2006, we erased it. We removed it from the family of planets and quietly assumed the story was over.
5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
But when humanity finally sent a camera into that distant abyss, the story began to collapse. Because Pluto was not dead. Something beneath its frozen surface was still moving. Still changing. Still rewriting the world itself. On a planet where physics says nothing should happen. Something still is. And the deeper we looked, the more impossible Pluto became. Pluto orbits more than 3.6 billion miles from the Sun, nearly 40 times farther than Earth, placing it in a region where solar energy is almost non-existent. At that distance, sunlight is 900 times weaker than on Earth, far too weak to drive any meaningful geological activity. The surface temperature falls below -370 degrees Fahrenheit, cold enough that even nitrogen becomes solid and behaves like rock. In these conditions, there is no liquid, no flow, and no natural process capable of reshaping the surface. Pluto is also extremely small, measuring only about 1,470 miles across, meaning it should have lost its internal heat billions of years ago. Small worlds cool quickly, and once that heat is gone, geological activity shuts down completely. Larger worlds like Mars have already gone silent, and even the Moon has been inactive for billions of years. By every known rule of planetary science, Pluto should be even more lifeless than all of them. No internal heat, no tectonic movement, no surface renewal, and no reason for anything to change. It should be a frozen relic, a leftover fragment from the formation of the solar system, locked in place and untouched for billions of years. That was the model, and that model explained everything we thought we knew about small, distant worlds. And if that model is correct, then nothing on Pluto should be moving. But when New Horizons finally sent back its first close images, that model began to collapse. At the center of Pluto's surface, scientists saw something no one expected. A vast, pale basin shaped like a heart, stretching more than 600 miles across. This region is known as Sputnik Planitia, and it immediately broke every assumption we had. In a place that should be covered in impact craters billions of years old, the surface is almost perfectly smooth. There are almost no craters at all, which means this terrain cannot be ancient. The surface here is estimated to be less than 10 million years old. On a cosmic timescale, that is effectively yesterday. Something is actively reshaping this region, erasing impacts as fast as they appear. This isn't erosion or decay. The surface is being renewed from within. A world that should preserve every scar is wiping its own history clean. And the deeper we looked, the clearer it became that this was not an isolated feature. This is a system actively rewriting its own surface. Something on Pluto is continuously erasing its past. The patterns on Sputnik Planitia are not random. They are evidence of motion. Each polygonal cell stretches between 10 and 40 kilometers across, forming a network that covers the entire basin. These shapes are created by convection, material rising from below, spreading, cooling, and sinking again. It is the same process that drives boiling water or molten rock deep inside Earth. But on Pluto, it is not rock that is moving. It is solid nitrogen behaving like a fluid. Warmer nitrogen rises toward the center, then spreads outward before sinking along the edges. The entire surface turns over continuously, like a slow-motion lava lamp in the dark. A single cycle can take around 500,000 years, but it never stops. This is constant motion on a world that should be completely frozen. Every rise and fall of nitrogen slowly erases the past and rebuilds the surface. That is why impact craters do not last. They are recycled back into the system. What we are seeing is not a frozen wasteland, it is an active system. Ice is moving, on a world that was never supposed to move at all. A system that should have stopped billions of years ago is still running. And that leads to a deeper problem. What is driving this motion in a world that should have no energy left? The motion we are seeing requires energy, and on Pluto, that energy should not exist. On worlds like Europa or Enceladus, internal heat is driven by tidal forces from a nearby giant planet. These forces stretch and compress the interior, generating enough heat to keep subsurface oceans active. But Pluto is alone. It is not orbiting a massive planet, and it is not being pulled apart by tidal stress. That removes one of the most powerful heat sources we know. The second possibility is energy from the sun. But at that distance, the sun is no longer a source of change. It is only a distant glow. The energy reaching Pluto is far too weak to drive convection or sustain geological activity. That eliminates the second major source of heat. What remains is internal energy, the residual heat left over from Pluto's formation. This heat is produced by radioactive decay inside the rocky core. But Pluto is small, and small bodies lose their heat quickly over time. According to every model, that heat should have dissipated billions of years ago. There should not be enough energy left to drive the motion we are seeing today. And yet the surface is still turning. The nitrogen is still flowing. The system is still active. This is where the contradiction becomes unavoidable. By the laws of physics, this shouldn't be possible. But something here is ignoring those rules. The observations say it is happening anyway. The math does not balance. The energy budget does not close. This is not a rounding error. It is a crack in the model itself. According to the equations, this system should have gone silent billions of years ago. But Pluto is proving them wrong. Scientists began testing a different possibility. Maybe Pluto is not generating more heat than expected. Maybe it is simply holding on to heat far longer than it should. The mystery may not be how Pluto creates energy, but how it refuses to lose it. One explanation points deep beneath the frozen crust. Pluto may still contain a buried ocean of liquid water, mixed with ammonia that lowers its freezing point. Above it, insulating layers could slow the escape of heat into space. A world once expected to freeze solid may still be thermally insulated from within. Another possibility comes from Pluto's ancient past. Billions of years ago, a massive collision with Charon may have reshaped the entire system. That impact could have driven enormous heat deep into Pluto's interior, delaying its cooling across cosmic timescales. Pluto may still be carrying the thermal aftermath of a forgotten catastrophe. None of these ideas fully solve the mystery on their own. But together, they point towards something unexpected. Small, frozen worlds may survive far longer than our models predicted. Pluto may not be an exception at all. It may be evidence that we misunderstood the outer solar system from the beginning. The deeper we look, the more the anomalies begin to multiply. Sputnik Planitia is not the only place where Pluto breaks the rules. Across the surface, we find entire systems that should not exist at this scale. Towering above the plains are massive mountain ranges rising nearly 10,000 feet into the dark sky. These mountains are not made of rock, they are made of water ice. At Pluto's temperature, water ice becomes as hard as steel, allowing it to form rigid structures. Some of these mountains are broken apart and drifting across the nitrogen plains like enormous icebergs. Solid mountains are floating on a frozen sea. Flowing down from the highlands, we see glaciers, but not made of water. These are glaciers of solid nitrogen, slowly moving across the surface over time. They carve channels, reshape terrain, and feed into the basin below. On a world where nothing should flow, entire glacial systems are active. Then there are the volcanoes, but they do not erupt molten rock. Reitmans rises from the surface, a massive structure over 90 miles wide and several miles tall. Instead of lava, it erupts a mixture of water ice, methane, and other frozen compounds. This is cryovolcanism, a process that requires internal energy to drive material upward. A world that should have no energy is still erupting. Surrounding the entire planet is a thin atmosphere, far more complex than expected. Surface pressure measures around 1 pascal, nearly 100,000 times thinner than Earth's atmosphere. And yet, this atmosphere is active, forming layers, moving, and interacting with the surface. Over time, Pluto's atmosphere expands and collapses in a repeating cycle as it moves along its orbit. The planet is effectively breathing, slowly exchanging matter with space. And across this landscape, a strange form of snowfall is taking place. Complex organic molecules known as tholins are formed in the upper atmosphere. They drift downward and settle on the surface, covering the terrain in a deep red layer. Pluto is covered in red snow created by chemical reactions driven by faint sunlight. Mountains, glaciers, volcanoes, atmosphere, and organic chemistry are all active at once. These are not isolated anomalies. They are connected parts of a larger system. This is no longer a single anomaly. It's a system. If Pluto is not what we thought it was, then the problem does not stop at Pluto. It forces us to look beyond a single world and reconsider an entire region of space. Pluto is not alone. It is part of a vast structure known as the Kuiper Belt. This region extends far beyond Neptune, filled with thousands of icy bodies orbiting in the dark. For decades, these objects were assumed to be simple, cold, and inactive remnants of planetary formation. Pluto was supposed to be the largest and most representative example of that entire population. But Pluto is not simple. It is not inactive. It is not predictable. That raises a deeper question about everything else out there. Objects like Eris, nearly the same size as Pluto, orbit even farther from the Sun. Sedna travels on an extreme orbit that carries it deep into the outermost reaches of the solar system. And beyond them are countless smaller worlds that we have barely observed. If Pluto can sustain geological activity under these conditions, there is no guarantee it is unique. The assumption that size determines complexity may no longer hold. The assumption that distance guarantees inactivity may also be wrong. Pluto was supposed to confirm our models of the outer solar system. Instead, it has challenged them. And if Pluto is wrong, then everything beyond Neptune might be wrong. We may have been looking at this region for decades without truly understanding it. The outer solar system may not be a graveyard of frozen relics. It may be a collection of active worlds, each operating under rules we do not yet understand. We may have misunderstood the entire outer solar system. Pluto was never supposed to change the way we see the solar system. It was supposed to confirm what we already believed. Instead, it exposed the limits of those beliefs. And once you see that pattern, it becomes impossible to ignore. Pluto is not the only world that behaves this way. Enceladus ejects plumes from a hidden ocean. Titan holds rivers of methane. Triton shows signs of cryovolcanic activity. These worlds are small. They are cold, and yet